Kaggle assignments are created by him only, so he will have a better idea of the issue that you are facing. So please tag him. He will respond and he'll help you out with the Kaggle assignment queries. Okay.
Okay, sure.
Yeah. Okay. Okay. Apart from that, yeah, I was telling about the OPP2, so I'll just tell it again. So OPP2 will contain the classification. So it will be basically from week 1 to 7, which is classification. Exclude your regression part. That is week 4 and 5 have regression, so you can exclude that. You will have around 10 questions of pre-processing, which will be very like similar in the sense that the formatting and all will be quite similar to OPP1, where you will have to do some statistics or do some pre-processing, feature selections and encodings and everything, which we have seen in OPP1 as well. Then in the model building part, you will get a data set. Again, formatting will be CSV file type data sets, which you have seen. And you're going to be building classification models. Okay. So whatever models you have learned for classification, which can include your decision tree, your logistic regression, perceptron, then neural network. Some of these models we have seen in regression as well. So these models are quite similar. So you'll just have to use the classification variations of these models. Okay, hyperparameter tuning like grid search, randomized search, cross validation. These things, of course, are same as regression for classification as well. So you need to be quite good with these things. And apart from that, the level is going to be quite similar to OPP1. So if you are comfortable with OPP1, then OPP2 should not be any problem. Okay, it will be very similar to that itself. Okay, so any doubt about OPP2, if you have, we can like about any general doubt, we can take that up and then we can begin with week 9.
Regression classification both will be there in the
No,
OPP2.
no, only classification will be there. So you can exclude it will be week 1 to 7, but you can exclude week 4 and 5 because regression won't be asked. So only pre-processing, pandas, and classification.
So what about the natural language processing?
Natural language processing won't be there in the OPP. No.
It is not covered in TS sessions, is it?
I think which week was it? Week 7, right? Natural language processing. So
No,
we
it was week 8.
week. Oh yeah, sorry. This is week 9. Yeah, week 8. So week 8 is covered. Week 8 has been covered on Thursday by Manoj sir. He has covered week 8. So he has covered NLP in that. So you can watch
In
Thursday's recording, I think, for that.
in
Thursday.
TA session, week 8 was left. Some of the parts are discussed only. They will discuss on Friday.
Yeah,
For
and for
week
instructor session, you can watch last Thursday's recording for the NLP. Okay.
You won't be covering that.
No, Manoj sir has covered it in week 8, right? So actually, Manoj sir covers all the even weeks and I cover all the odd weeks. So for this time, I will be covering week 9, 10, 11, all of them, and then sir will be back for week 12
Oh,
after that.
okay. And in the mentor sessions?
Mentor sessions will be covered like the TA and mentor sessions. There are two TAs, so they cover all the weeks. In case they have missed me week 8, I'll just tell them to cover it in the next session.
Okay,
Okay,
sure.
so that they
So
can cover it.
actually, the thing is that due to OPPs, we have they taken session for OPP in one of TA taken week 7 and week 8 TA session
Okay.
together. But for Friday sessions, sir took previous week 7. Sir said that this week they will be taking week 8.
Okay, yeah, then it's fine. When do you have the sessions? Like on Friday, right?
Yes, sir. Friday and Tuesday.
Yeah, so Friday they will cover weekend, and next week then they can cover week 9.
Yes, sir.
Yeah. In fact, what about tomorrow? They have a session tomorrow as well, right? Tuesday.
Sir, that was taken by mom, so I think they will take week 9.
Okay, week 9. Okay. That's okay. I'll still inform them to cover up week 8 as well on Friday.
Yes,
Tomorrow
sir.
is week.
Sir will going to take a session for week 8 only on Friday. They confirmed in last session.
Yeah, then it's fine. Right now, then okay. So we will be covering week 9 right now, and TA session will cover week 8. That is good. And for week 10 and 11 and 12, we will cover it as usual, like on Monday, Thursday sessions. And in between, whichever week there will be the OPP, so we will replace one session with the OPP revision, just like we did in OPP 1, right? So, and actually, the upcoming weeks 9, 10, 11, 12 are not very difficult. They're quite easy weeks. They are not traditional. Like this 9 is very simple. It's on clustering. You must have seen it in MLT. 10 and 11 focus on time series and some other aspects which are quite new. Like it was part of the revamped syllabus of this course, but they are quite important topics. And in fact, I think this time I heard that the project also is on time series, right? So that's quite good. So we'll cover all these weeks. And for the OPP, you don't need to worry. You have to just focus on the classification models. But after the OPP for the end term, all the weeks are equally important. So you have to focus on everything.
So last Thursday we're talking that week 8 was covered,
Yeah, last Thursday. I think
but
last
but
Monday there was no session. On Thursday
uh,
there was a session.
Yes, sir.
there,
Yes, sir.
there is no recording for Thursday session.
There is, I think it got streamed on YouTube as far as I remember.
Yes, sir. It's streamed on YouTube.
But
Yeah, it's streamed.
in the calendar there is no link showing.
Okay, just you have the access to the YouTube channel of MLP.
Okay, sir.
Yeah. So just access it from the YouTube. Okay, I'll tell sir to update in the calendar. I might have got missed, but just on the YouTube it is there because I saw it on YouTube and it was there.
Sir, please update in the calendar, because the date wise only in the calendar it can be traced. Otherwise,
Sure.
it is
Sir,
very,
actually, sir and I update the recording and calendar, but it's just I think once it got slipped, so we'll upload that.
yeah,
Whichever
because
got
the sequence could be maintained there. No?
Yes, I understand. Yes, we will upload it. Sure. Okay.
Is there any session regarding the project?
Yeah, I think on every week session happens with Anirudh, the instructor. He takes project sessions, and I don't know the exact date when it happens. I think on Friday, if I'm not wrong.
Recording of the same is also available.
Yeah. Recording is available. All the sessions that are taken, the recording will be there in calendar as well as they will be there in the channel. Both the places. Okay, so you can access.
Is it the same channel of machine learning practice
Yeah,
or
same channel.
Project session is every day.
Yeah, that is I think with the TA it is every day, but with the instructor it is once.
Yeah. For TA it is every day.
Yeah. TA is because to assist and help out in the project, right? Doubts and all. That's why it is every day. The
So
instructor-
when it happens every day, I mean the link for the same.
It happens with the same link, I guess, or is it a different link?
Maybe the person who
This
have
is the link. I'll just
registered
share
for
the
the TA.
link. It is on 7 p.m. every day. So I'll share you the
Yeah.
link.
Correct.
This one is the link.
Yes.
This one. Okay, 7 p.m. every day.
And who is the concerned person?
Who is the?
Concerned person, I mean, who takes this session every day?
Arvind.
Yeah, the TA, I think. Arvind, right? Okay. Yeah, TA. So this is for the TA, and weekly one session is taken by the instructor for this.
Okay, thank you.
Okay, so if you are having any doubts on the project, just join this tomorrow or any day you are free so that you can clear it. Right?
Actually, I did not check the project at all, so I started looking into it and lot of confusions I had.
Yeah. So join the session. I think they will help you out with that.
Thank you.
Yes. Okay, sure.
On the Kaggle assignment also session will be there some.
Kaggle assignment, I think on the project session you can ask about Kaggle assignment also because the project session covers the it's taken by the same instructor, so he can help you out in the Kaggle assignment as well. This is which Kaggle assignment? The second one or the third one?
Second one.
Okay.
Sir, second.
There are just 2 Kaggle assignments, right? Is there a third one?
I think there are 3, right? As far
Three
as
Kaggle assignment. Second has been released. Third one is due.
Yeah, third one will be on the last few weeks. So it will be on the I think the NLP or something like that. So last week.
Yes, sir.
The second one was
quite new. That's why we are not giving in the OPP.
Second one is classification.
Yeah. And third will be on that one of the advanced topics. Because the advanced topics we are not covering in the OPP because they are quite difficult for the first time. That's why we are giving it in the Kaggle assignment and in the end term as well. Regarding end term will be code-based questions. Okay, so you have to. It will not be on syntax memorization, but you should know the general syntax and the flow. So if you know how each of the things are working, then you can answer the questions on end term. And of course, for end term, you have access to past year questions as well, right? So you can have an idea of what kind of questions will be there. But just think that it will all be code-based. Okay, mostly like 99 to 100% questions will be all code-based.
That also OPV or we need to go to center?
No, end term is in center, just like all other end terms. Yeah. You will have that, just like Python has the end term, right? Where the snippets are given and you have to answer code snippets. Like that.
How the answer collab sheet will not be there?
No, nothing will be there. But it won't require, like, it will not be
Okay.
memorized syntax based. It will be, the code will be given. You have to answer something based on that, based on logic only. It won't be like
Okay.
syntactical.
Theoretical type of thing.
Theoretical type of questions, or maybe like one example can be, I give you two numpy arrays in a code and I ask you compute the mean square error. I give the code, you have to identify what loss function it is computing, and then you just compute it by hand with the formula. So it will be like that.
Okay.
Yeah. So just, you can have a look at past year papers. It will give you an idea.
Sir, I shared the link.
Yeah, that will be good. So thanks,
Correct.
Rishabh. So
Thank
you
you.
can
Thank
just
you.
have an idea.
Thank you, Dish.
But
And
syntax would be like, you don't have to memorize all syntax. Like, this model has this parameter, this parameter, this parameter. This you don't have to memorize. But the basic, like, what is the use of, like, we have to create a class. Then what does one hot encoder do? What is difference between fit, transform? These types of basic things we should be knowing. And this you will be right, because since you are doing the coding since 12 weeks by that time, that would be quite easy to answer questions based on that. Okay.
Okay, sir.
Yeah, and we'll have revision sessions, so you'll get an idea of what kind of questions are there. So that won't be.
Okay.
Yeah.
One more
regarding
question I
Kaggle
have
assignment,
regarding
the
Kaggle.
concerned person is Aniruddha, eh?
Yes. He's for Kaggle assignment as well as for project. For both, he's handling.
Okay, thank you.
Yes. For the course part, that is the theory and the live sessions, the quiz, the OPPs and Anthem, it will be Manoj sir and me. And for Kaggle assignment and the project, it's Anirudh. Okay.
One silly question about the Kaggle is
Yes.
that actually, suppose one submission I have already done. I want to do the second submitted option correction something. The new notebook should I use, or the same notebook I should use?
I think you can use same notebook for correction.
Then the
Because
previous
in
one,
project and everything also we use same notebook only.
the
So
previous one version will be there.
Previous, yeah. You have to do save version in Kaggle. So when you click on that save version, you can find all the versions previously. So you can access. Okay, so whenever you submit, just first there's an option called save version. Do that and then submit. So that saves all your version. You can retrace anytime to the previous version.
Okay, if you want go to the previous again, and again you submit that will take.
Yeah. It will take, no problem on that. It will take. Just remember to save version. Okay, that is the important.
We can make trial on that for the
Easily.
improving the score.
Yes, absolutely. You can work with any version, it won't be a problem. All versions are saved. Just you have to make sure that you click the save version button.
And for the improving the scores, only we should the models change and just check it. Is it?
Yeah, you can change model, you can add some pre-processing and something, and then just submit again. That would be something good. You can work with that. The best way of improving score is getting better model, and then you can try hyperparameter tuning, and then you can even try some more pre-processing to improve and just see which, like, outlier detection or something like that, which helps to improve. But generally for regression and classification, good models and hyperparameter tuning does a good job mostly.
Yes, the Kaggle assignment too had nice results. Everyone
Yeah.
saw on the leaderboard. Yeah.
When you use that one,
Cutoff is high, na?
if cutoff is high, that means scoring will be slightly easy. That is the general implication, because I think for project the cutoff is quite low because scoring is difficult in that. So it is very it is tentative. Like, it depends on the data, the model, and the average scores and things like that.
Okay, sir. Okay.
So what is the cutoff? I got 89.
I don't know for Kaggle assignment actually.
89 means
It
100%
will
score.
definitely be above cutoff only. It won't be that high.
Yeah, 0.89 is highest score.
No, 9 is highest.
No, highest means not a score high. You will get full marks.
Achha.
Okay, let's start with week 9 then. OPP, for OPP2 we'll have more sessions as it comes closer, so that time we will discuss it more. Okay,
sir.
week 9, as just like week 7 was one of the easiest weeks. It was quite simple to understand. Week 9 is also just like that. There are only two things you have to focus on in week 9. One is k-means clustering and one is hierarchical clustering. Okay, so these are just two variations of clustering, and I'm sure you have seen them in MLP. Hierarchical, if you have not seen, we will discuss the concept as well in the next session. K-means is something everyone knows. Can somebody tell me, like, what is k-means used for? Can I use it for classification? Is it possible to use it for a classification task?
Yes, sir.
Is it? Like, are you sure? K-means falls under a paradigm called as unsupervised learning, right? So what is unsupervised learning? Unsupervised learning means when you have data but you don't have a label for it. Supervised learning means when you have data and label as pairs, right? and classification is only possible when you have supervised learning. So k-means, because the label is not there, k-means cannot be used for classification, but k-means can be used for understanding and grouping the data. Like for example, the data set I've taken here is very simple. I have created it only. There are some age groups given to you and there are some income groups given to you. Now, generally what happens is some people will belong to higher income groups, some people will belong to lower income groups, and some people will belong to moderate income groups, right? So what k-means will do is it will just group the people who are together. Like basically the higher ones will get grouped together, then the lower ones will get grouped together, and the medium ones will get grouped together. That's what k-means does. It does not do any classification because there is no label, but it helps you to kind of get an idea of what classification will look like by grouping similar people or grouping similar attributes together. That's the basic crux of k-means, right? Can anyone, if you remember from...
So it can classify the data, but it does not know about the significance of that. I mean,
Yeah,
how does
because
it
there is no
mean?
actual label, right? So you can classify it by, basically you can group it like this is a higher income group, but there is actually no label. So it's called as higher income group in this case. You can group it and understand it. Okay. Yeah, I'll also come into one use case of k-means towards the end of the session. We'll not solve it because it's quite advanced, but we'll discuss it. So maybe you can explore it later on with some data set and try it out. It is called as market basket analysis. It's quite used in management and sales. So we'll discuss it towards the end of the session. Okay. So does anyone know like how k-means works? What is the phenomenon of k-means? Like how is this grouping or clustering possible? What do you group based on? Like how do you know things are similar?
Distance.
Based on the
mentioned
distance
distance, right?
between them.
Yes, distance. So basically the points which have less distance between them, they are similar. So we can group them into a cluster, right? Cluster
Yeah.
is just a group, another name for group, right?
Yes.
But to standardize the process in k-means, what we do is instead of taking distance between every point, we start with some initial points, right? So suppose we say we need 3 points. So we'll start with 3 clusters. Let me show it in a diagram so that it's easier to visualize. Okay. So k-means diagram. Sorry,
I think
diagram.
we update we first do mean and then we update the mean again. Like that.
Yes. So basically, exactly, that is the correct answer. So see what happens is if you see data is in this format, right? And here you can see that some of the points are on the higher side, some of the points are on the lower side, and some of the points are quite in the medium side, right? So we know these points are similar, these points are similar, and these points are similar. So what we start with is we take any point from all the three, like 1 point from here, maybe 1 point from here, and 1 point from here. Then what we do is these points are called as centroids. These are the initial points. Okay. Once we get these centroids, what we do is we try to map these centroids and we get the distances of all the points from these centroid. So this point from this centroid, this point from this centroid, this point from this centroid, and so on. Right? Once we get the distances, we will map the points to the centroid they are closest to. Right? So this point, for example, will get mapped here. This point will get mapped here, and this point will get mapped here because these are the closest centroids, right? Based on the distance metric. And once these points are mapped, we will again recompute the mean, we'll again compute distances, and we will keep going on until and unless we reach a stage where no point is in the wrong centroid. What do I mean by a wrong centroid? Can somebody give me an example of what is a wrong centroid?
If the distance of
For
that is
Distance wrongly calculated. I mean, it is closer
Like,
to
can I say,
one center,
can I
but
say,
wrongly labeled to the other group.
can I say a blue point
yeah,
is
it is a
mapped to
green.
the green cluster? Is it a wrong centroid?
Yes, it is
It is,
wrong.
right? Because the distance of the blue point is less to the least to the blue cluster, but I've still mapped it to the green cluster where the distance is higher, right?
Hmm.
That means a higher income group person got mapped to a middle income group cluster, right? That is what the practical implementation is. Or a customer who buys 10 kilos of rice got mapped to a customer who buys 1 kilo of rice, right? That's what has happened because we have to group similar things together in clustering and different things have to be apart, right? So instead of doing that, we have done the opposite thing. So that is the wrong centroid. So till when does k-means continue? K-means continues in iterations till the point we arrive when there is no wrong centroid. That means all the blue points have been mapped to the blue cluster, all the green points have been mapped to the green cluster, and all the black points have been mapped to the black cluster. Okay. So once we achieve this kind of a positioning, we can stop k-means after that. Okay. That is the idea. So three main things. One is k-means is unsupervised. That means there is no label. So it is just used to group similar things together. Second thing is k-means works with centroid. So you have to take some random points initially, then compute distances of every point to all those centroids and assign them to the centroid where it is nearest to. And finally, k-means will continue doing this cycle until and unless it reaches a place where there is no wrong centroid. And what is a wrong centroid? Wrong centroid means that the distances were less for some other centroid, but I have mapped it to another centroid where the distance was more. Okay, so a wrong mapping. So once we have reached a situation when there is no wrong mapping, we can make sure that k-means has successfully converged. That is the idea. Okay, now you have seen k-means in MLT, so I'm not going into the mathematics of it. In case if you have a doubt, we can discuss. Otherwise, we can go to the coding part.
The K is the hyperparameter in that, no?
Yes, exactly. Because that depends on how many clusters you want to divide, right? So suppose I say I want to study my customers in 4 income groups rather than 3. So I'll take 4 clusters in that case. So it's just like, see, if you are comfortable with KNN, it's just like that. In KNN, we want to see
Okay.
how many neighbors I want to compare, right? So same thing here. How many clusters I want to compare.
Okay, fine. Got it.
Yeah. So this was about, yeah, K is the hyperparameter.
Sir,
Yes, sure, Dev.
yeah, sir, I'm telling that so K means and there is one also K neighbors. So what is the difference between these two?
So k-neighbors is a classification algorithm, right? So it basically has label. So you have to basically, what happens is, suppose I say 5 neighbor algorithm. That means I will, for each point, I will compute the distance to 5 lowest points, nearest points, and then I will see what label those points have. If those points have label 1, then my current point will also get label 1. Here I'm not assigning any label, I'm just grouping the points together. So it is actually very similar. It's just that instead of assigning a label, this is just grouping them, and there we were assigning a label, specific label. That's the only difference. Otherwise, the algorithms are quite similar, almost the same. Okay. The main difference is there was a label in KNN. That was what we were assigning. And K means we don't have any label. So we are just grouping close points together. That's the main thing. Okay. So the use case is different. Rest, the working of the algorithms are more or less on the similar side. Okay.
Okay, sir.
Yeah. So any other
Okay,
question
sir.
on k-means, like on the theoretical part? Theoretical part, like from MLT, if you are clear with that is sufficient. It won't be like discussed much. But if you have any other doubt, we can talk about it. Otherwise, we can go to implement it. Shall we implement? Okay.
Yes, sir.
Yes, sir. Yes.
Yeah, right. So let's implement. So again, data set I have created with pandas. So I think it's pretty clear. We have 2 features, age and income. And based on this age and income, if you can see, some ages are less, some are more, some incomes are less, some are more, right? So we will be basically doing a grouping, right? So let's begin with that. So for first of all, one important thing, whenever you work with algorithms such as KNN or K-means, scaling is very important. Okay, feature scaling, which we have seen, KNN, K-means, linear regression, these algorithms are very sensitive to feature scaling. The reason, I think I've told it before as well, the reason is that in KNN, K-means and all, we calculate distances, right? So when you don't have algo features which are scaled, distances become very rough. Like for example, if I have feature values like this, 45,000, 90,000, 62,000. Then I have small values also like 39,000, 34. These are small values, right? So features are very unevenly distributed. For some, I have to calculate very large distances. For some, I have to calculate small distances. So it's very uneven. So the algorithm is not very stable. Once I scale them using min-max or standard scaler, the values always shrink, right? They become very small and they become in a close range. So computing distances becomes very easy in terms of that, right? So that is why whenever you have algorithms which have involvement of distance, to make sure that the distance computation is easy and the distance computation is not hectic for the machine, we make sure that we scale them. Okay. So this is a question which has been asked in multiple times in your previous terms as well. So which algorithms need scaling? So the algorithms which have involvement of distances, they need scaling. Okay. Algorithms which have no involvement of distances, there is no point of scaling them. You can even ignore scaling in those cases. So can you give me an example of one algorithm which does not require scaling? Like any algorithm from regression, classification or something? Decision tree requires scaling, or do you think it doesn't need any scaling?
It does
Does
not
not need
need.
it.
It does not
Does
need.
not need.
Because
Does not
decision
need.
tree just
No,
asks
sir.
questions, right, on the features. There is no distance. It is computing. So it does not need scaling. Random forest, no scaling, because again, it's just a mixture of trees, right? Add a boost, no scaling. Neural network also does not compute any distance. So no requirement of scaling. You can scale, obviously. It does not mean you can't scale, but there is no requirement. For algorithms like KNN, K-means, it is good to always scale because that's the standard practice, right?
So when we are comparing the feature value directly, then there is no scaling. I mean, suppose all the tree algorithm, we are comparing the value less than greater than, and
Yes,
accordingly
yes,
we are
yes, exactly.
distributing.
Then there is no scaling. But when you are measuring distances between points like Euclidean distances or Manhattan distances, then you need scaling, right? Because I think the reason is pretty simple because if there is no scaling, the distances are very large for some values, very small for some values, so it's very uneven. When you scale, every value is between either 0, 1 or -1 and +1, so it's a very small range, right, for all the values. So computing these distances become very easy for that case. Okay, that's the only reason.
Okay.
Okay, so let's scale them. So can somebody recap how the scaling has to be done? Because this we are seeing since week 2 now.
If the data is categorical, then here
Then encode and then scale. First
okay.
encode, then scale. After
It
that.
means it must be numerical for the processing.
Yes, yes, yes. For all algorithms, you have to first convert, and after converting, we can scale them with a
Okay.
min, max, or standard, whatever, like any scalar, we can scale them.
Okay.
Okay.
Sir, can you repeat for
So
categorical
let's do
how do we
standard scalar
encode
first.
and then scale?
So first apply one-hot encoder, and then you apply scale the min max scalar on the one-hot encoder, because after applying encoding, it will all be numerical, right? So you can do the scaling directly on the numerical values.
So if there are three categories, then 1, 2, 3, and then scale 1, 2, 3.
Yeah. So basically,
Okay.
you see one-hot, yeah, 1, 2, 3, that will be your one-hot encoding, and then you scale them. Exactly. Yeah.
Okay.
Because once you have encoded them, they are numbers, right? So numbers you can scale normally only. So that's why through 2 steps: first encoding, then scaling. After that,
Sir, can we do standard scaling?
yeah, any scaling, min, max, standard, anything you can do. Okay, any of them is fine.
Okay, sir.
So let's go with standard only, since standard is quite good. Like there's no bias. Like you can even use min, max. There won't be much difference. But let's try with standard for this particular session. Okay, so let's do. Can someone tell me where is standard available? By now you should know after one OPP.
From Askelin dot
Yeah,
preprocessing.
so it is given us. So let's just replace. We can use min-max also, but I wanted to go with standard. So let's do that. Okay, so let's do standard scalar.
Sir, in Kaggle, why does the suggestions not come? Like even if I've written 2, 3 letters,
I think because Colab has some additional features which gives it to us, but Kaggle is quite backdated. It's slightly an older version of the notebook. Colab gets updated very frequently. Kaggle does not.
it's quite
I
basic
think
to
even
like
this
process
AI
all this.
feature is not there in Kaggle, right? This
No,
generation.
no, no.
Yeah. Kaggle is old.
Nothing was there, sir.
Yeah. Kaggle
I
is
mean,
having old versions of notebook. Colab is much more advanced than that.
one typo and you will get an error. So it's quite basic. It should have it.
It should exactly. It should have it, but with Collab, the things are much better right now. Like if you take Collab Pro, then you will get many more GPU features as well, which are much better than Kaggle.
Copy the code in the Kaggle first and do parallelly.
Yeah, that you can do. Like basically write the code on Collab, then just put it on Kaggle and run. So that can be helpful in
Yeah.
that case. Yes. Okay, so let's create a class. So let's call it scalar. So let's create a class of standard scalar. And what is next after this? Can someone tell me like what do we use? Do we use fit? Do we use transform? Or do we use fit transform?
Fit
Fit
transform.
transform.
Yeah, because we are learning the mean and variance and we're also transforming the values, right? So we have to use fit transform. Okay, so let's do.
Pardon. What do you tell?
No, I was telling that we have to do fit transform, right? Because first we'll fit the scalar to learn the mean and variance, and then we will transform the values with the scaling formula, right? So we have to do fit transform. Whenever we are pre-processing, we'll be doing fit transform. Whenever we are building a model, we'll be doing fit because we are not changing the values there, right? We're just learning the parameters.
Yes, sir.
And only what case only transform?
Only transform is used for when like it's not much used. Like earlier some preprocessors used only transform, but nowadays all the preprocessors are very advanced, so they learn and then they transform. So we mostly use fit transform. There is no like traditional case for transform right now. It's outdated kind of.
I mean, our questions I have seen when XY split is done, then that at the test case we do transform only.
Yeah, that is after model building. Yes. So that is after that is also a case.
What
Exactly.
that I
That is a
cannot
case.
understand why we do that transform only.
No, because with the training data you learn, right? You learn the parameters on the training data, but on the testing data you don't learn any parameters. You have to just apply the learned model on the testing data, right? So that's why we don't fit on it. We always transform.
Okay.
Because all the parameters that your model learns, whether it's a preprocessor or a model, all the parameters have to be learned on the training data. If I show my model the testing data, then the testing data becomes seen data, right? It is not unseen anymore. So I should not transform fit on test data. I can, but I should not. That is a standard practice. That's why we use transform.
If you don't transform the X test data, then a result will come in that test after
It
fitting
won't
test.
come, right? Because if you have encoded the training data, then your test data has not been encoded, because transform is required to encode, like apply the preprocessor, right? So if you have not encoded, then your model will fail, right? Because it needs numbers. So you have to preprocess the test data also.
Okay, that is also required to be.
Yes, because otherwise, for example,
trans-
boy is 1, girl is 0 in my model, but my test data sees the word boy. It will not be able to run the model on that, right? It has
Okay,
to
that
get
yeah. It means if transform is required when you process
It is required.
for the
Yes,
model.
it is required.
Okay.
Yes.
But in case of like Kaggle, we get the test set and train set. It means that is already pre-processed.
No. You have to preprocess the test set as well. You have to.
Okay.
So whatever pre-processing you have done on the train, you have to do it on test as well before submitting. Otherwise, it won't work, or it will give you a bad score.
Pre-processing should be done like fit transform on the train and
transform on the test. Yes.
Okay,
Simultaneously
okay.
do it for both of them.
Okay, fine. Thank you.
Yes. Joydev, any question?
Sir, the way we are practicing, like we get only one collab, one data set, and from there we are doing splitting. So in Kaggle, this is not required, isn't it? To
No,
split?
because it's already split for you. It is not required.
Yeah. Okay, sir.
Okay. So Kaggle, we are already giving you 2 files, right? Because in the test, the label we are not giving, right? That's why we are giving you 2 files. So the train and test separately. So no splitting required.
Then Y is required. No, we have to get Y also. No?
Yeah, feature level split you have to do, but train test split you don't need to do. That you can skip.
If it is not mentioned, then we have to select the level.
Yes. Label you have to select, but the training and testing split, the train test split thing, that you can skip, because test is already split from train, right? When you're doing it in Kaggle.
And what basis we should select the level if it is not mentioned?
It will be mentioned. Otherwise, the answers will become very random if everyone selects a different label. So it will be mentioned.
In GA8, I think mentioned. It was not mentioned at all. The sentiments was not mentioned.
Not mentioned. Okay.
See,
but if we
nothing was
don't get the data, then how will we just compare the models, different models, 7 models we have to compare?
That is what I'm saying. That is the requirement. In the question, nothing has been mentioned.
That might be some typo in the question. Then I will just look upon
Which
it. Which
question number?
I think
And which
GA8.
GA 8.1 or GA 8.2?
8.2 perhaps. I think I don't remember, but somewhere I found the sentiments was not mentioned. We separated it and did it because that was the only classification part.
Okay, I'll look into it. Okay.
Okay. Just see the question.
Give me a tag on discourse with that. Just anyone. I'll just look into it. If something is missing, we will add that and update that question. Otherwise, if the question is incomplete, we'll make sure that something is done on that. Okay.
Okay, fine. Okay, I will comment in that. Okay.
Yeah. Please.
Please proceed.
Okay. So scaling is done. Let's do the model building now, because scaling is the only pre-processing that's required. So let's go to model building. Okay, now for k-means, the model is again in a sub-library, and that is called as cluster. Okay, so sklearn.cluster, that is the name of the library. So we'll call it from sklearn.cluster, and we will import k-means. Again, there are multiple clustering algorithms. We'll look at one more in the next session. So both of them are available inside this cluster library. Okay, again, the first thing is same. You have to create a class, right? Of any, like just like KNN, decision tree, linear regression, you always create a class in the beginning and then you fit the model, right? So same thing we will be doing in the k-means case as well. Okay, so let's create a model. So let's call it like k-means. So k-means is a model of k-means. Do you think I need to add something here, like some parameter here? Do you think it needs to be added, or I can just proceed like this? Is it fine?
How many clusters?
Yeah, how many clusters, right? I can proceed like this also, because it will take the default of 5. Okay, that will be there, or I think 3 is a default. Just check that once. But if I have to specify, right? Because in my problem, I'll be given how many clusters I want. So it has to be specified, right? So let's just take 3 clusters for now. So we want to do 3 clusters. So that will mean 3 groupings, right? Based on the age and the income. Okay.
Put the value directly or equal to that.
No, value directly. It understands. It is number of clusters. Otherwise, the name of the parameter is also there. That is called as n clusters. So you can put it like that as
So
well.
we can put n clusters is equal to that.
Yes,
like
yes.
that
Actually,
also.
that is the better way of putting it. That is the better.
Yeah, that's why I say please start with that, because we should learn what is the name of the parameters.
Yeah, n clusters. Yes, that's only
Yeah,
one parameter
yeah.
there, which is n clusters.
Yeah,
You can even add
please.
the random state here. That is also possible. So
Okay, but that
just
is
like
fine.
you do it in tree and all, no, random state that also can be added. Let's just add it only, because in the OPP, if it comes, you have to add, right? So let's add it. Okay.
Okay, fine.
So you can change these values, and that just like KNN, you have the n neighbors, right? So you have n clusters here. Same thing.
Okay, fine.
Okay. Yeah. So the cluster is created. So now the model is ready. So we can do the fitting, and that will do the job, right? So we can do k-means dot fit. So just one thing which is going to be different here, in the normal models you do this, right? X, Y. So now there is no Y, right? That's only X, and that X is called as DF here. So they'll just fit the DF directly, right? So you can see the model is ready. There are 3 clusters. The random state is 42, and the model has been fit on the data. Any questions so far? Pretty simple, right? Just same as before. It's just like in the fit method, you had X and Y earlier, but now since there is no Y, so we'll just fit the X.
Yeah,
right?
okay.
Okay, so that is done. So now how do we see what are the clusters, right? We have to see that as well. So to see that, you have to use some attributes, because there is no label, right? So there is no label. So you have to use attributes to see what clusters have been predicted, what value gets which cluster, which data point is given to cluster 1, which is given to cluster 2, which is given to cluster 3, and so on, right? So that you can do in multiple ways. So one attribute, we'll see the attributes one by one. So the first attribute that you can see is label. So again, just you can go through all these attributes. So we'll see the first one, which is labels, right? So let's see this. So now you can see there are 10 points. The first point went to cluster 1, second point went to cluster 2, third point went to cluster 0, fourth point went to cluster 0, fifth point is 2, sixth point is 2, and so on, right? So whenever we have to see which point got into which cluster, you will be doing it by the parameter called as labels. Let's do one thing. Let's change it to 5 and let's see what's the difference, right? So
No,
now
sorry, if the many data is there, the classification, how we will go to which is the index? Which
I
point?
didn't get the question. Can you repeat once again?
Which point? Suppose which index went to the which level?
So like that, you could, this is index 0 went into this label, index 1 and went into this label, and so on. So for example, you want to see which index did data point 500 go into. So just you do the indexing of 500 here, right? And then you will get that value. Like for example, let's do 5 here and let's see what we get. It's an array, right? So you can just index it, and the value is 4. That means this went into cluster number 4.
It is showing index.
This is the index. No, this is the cluster number. This is the index of the data point, and this is the cluster number.
So how many clusters are there? 5.
No, I have changed it to 5, right? Just to show that it works with 5 as well.
Yeah. Okay.
Let's go back to 3. I'll explain it once again. Let's go back to 3 and let's try to understand once again. So the output of k-means.labels is an array, and this array is the clusters, right? This means the first point, that is index 0, went into cluster 1. Index 1 went into cluster 2. Index 2 went into cluster 0. Index 3 went into cluster 0, and so on. Okay. So for example, I want to see which cluster did the point in index 5 go into. So we'll just do the indexing of 5 here, and this will give me the cluster.
Okay.
Yeah, so this is just an array of labels of the clusters, and we can just map them to the data point. That will give us the exact cluster and point mapping. Okay. Yeah, so this was about labels. Now there is one more thing. So this is about basically how you build the model and how you see which point went into which cluster. After that, obviously, there is one more thing which is missing. Can somebody tell me what is the next thing? After model building, what do we do? We evaluate it, right? How good it is. Like
evaluate.
Yeah, so you have to evaluate. So let's evaluate. So in regression, you have mean squared error, mean absolute error. In classification, we saw so many in week 7, right? F1 score, accuracy, precision, and so many things. In clustering, there are 2 main metrics. There are many metrics actually, but the 2 main metrics that are important for us in the course and as well as in the industry, if you use clustering, these are the 2 usual metrics that are used. One is called as the inertia, cluster inertia, and the second is called as chill out score. Okay, so let's see both of them. So inertia is very simple. You don't even need to import anything for the inertia. So you have an attribute itself. So what you can do is you can just write k-means dot inertia. Okay, I think this you have to give. So once you give it, this is your inertia. Again, inertia is what? So does anyone remember what is inertia? Like from the MLT course, this was covered, the formula, if you remember. Otherwise, we can discuss the formula as well.
No, sir.
Formula is nothing. It is just that inertia is a sum of squared distances of every point from its cluster. So basically, what does mean that means is, I will take, suppose I take this cluster. This is the mean. Okay, this is the cluster mean. For example, I'll take the distance of this point, this point, this point, and all the points of this cluster from this mean, and I'll sum up those distances. Then I will add the distances from this cluster, this point to this cluster, this point to this mean, this point to this mean, and so on. And then for this cluster, right? So for every data point, whichever cluster it has gone into, I will compute the distance of that point to the mean, right? And once I compute the distance, I will just add up all those distances and I will get the final value, which is called as inertia. So can you tell me, based on this, is a higher value of inertia good, or is a lower value of inertia good?
Lower value is good.
Lower
Lower
values.
value, right? Because
Lower.
what do we want? We want the similar points to be grouped together, right? That means we want the distances between the cluster mean and the points to be minimum. That means the clustering has been very good, right? So if my distances are very high, that means the clustering is very bad. I have done some cluster misarrangement, right, which we were talking about in a while back. That means a high income person has been transferred into a middle income group, right? Those type of mismatches we have done. If we have a low inertia, that means the cluster points are very close to the mean. That means the mapping has been very good. So just like mean square, this is just similar to mean square error only, right? So when your mean square error is low, that means all the regression has happened well, right? In the same way, when the inertia is low, all the regression, all the clustering has happened well. That's the only.
This inertia is the mean of the inertias, because three
No, it's a
inertia.
sum. This one is a sum. It's not a mean. So mean squared error is a mean. Inertia is sum. Because actually, traditionally, when the clustering
No, I am
algorithm,
telling here there are three clusters are there.
yes,
So three inertia will be there.
yeah, it's a sum of all the three. Distance sum of all the three.
Okay, sum of three.
So basically, let's look at this. This means the distance of point 1 from cluster 1, because that's its cluster, right? Distance of point 2 from cluster 2, distance of point 3 from cluster 0, distance of point 4 from cluster 0. So I've just added up distances of all the points from their clusters and just summed them up linearly, right? So it's a linear sum. Okay, I'll just mention it here as well. So linear sum. And inertia is just a name given by sklearn. The actual name of this metric is called within cluster sum of squares. This is the name. So I think that is pretty understandable, right? Within each cluster, we are computing the sum of squared distances from all the point to the cluster mean, and then in the end, we are adding them all up, and we are getting this final inertia.
Okay, both are different way of calculating, right?
Yes, different way of calculating.
The linear sum is the every point is calculated from each cluster.
Yes, each cluster, every point. Okay. And of course, one more thing I'll add, which is lower the better, right? So that is what we know. So just think of it like mean squared error. Okay, so think like MSE. MSE is a mean, of course, it's not a mean, but the idea is very similar, right? We are comparing distances between the label and the point there. So it's the same thing we are doing here as well. Think like MSE, lower the better. Okay, so that was about inertia. Now with inertia, there is another metric called as Shilhout score. Shilhout score is, again, don't go into the formula of that because it's slightly a complicated formula. What Shilhout score represents is just like R2 score. Okay, R2 score means how much of the variance of the data is my regression model able to explain. In the same way, Shilhout score is how much of the variance of the data is my clustering model able to explain. So do you think it should be higher or lower for a good model? What should it be?
Higher,
right? Because I want my model to understand my data well, right? That variance means understanding the data, right? So if my model understands my data well, the score and the variance explanation should be higher, just like R2 score. Okay. So Shillout, I think, is present. Yeah, Shillout should be present in the metric library. I think it's not an attribute. Let me just verify. Yeah, it's not. So we have to import it from metric. Okay. So from sklearn dot metrics.
A score is always 1 minus error.
No. It's not 1 minus error. No. It has a different formula. It's just that a score means those metrics which are higher the better, and error means those metrics which are lower the better. That's the only thing. The formulas are all independent. They're not related.
Okay.
So the line is you maximize the score and you minimize the error. So that is the main thing. Okay, so this, I think, metrics library everyone has seen now for regression and classification. Same thing we'll be doing for this as well. Now, how do we actually do the scoring? So if you remember, in the regression and classification, we add the true label and the prediction, right? Here, there is no label. So what we add is we add the data and the cluster number. That's all. Okay, these two things we have to add. So you have to write Shilhout score, add the data, which is df, and add the label. So let's just call this as labels here, or clusters. Let's call it as clusters and just add this up. Okay, so data and the clusters. Okay, so the 61, that means the model is able to explain 60% of the data, so it's very average. It's not a great model, but it's not a bad model either, just like R2 score, right? As close as it is to 1, it is the better. As close as it is to 0, that means the model is not learning at all, right? 61 means
We are adding
Hello.
this DF on clusters. Adding means the score means we are calculating based on the formula. Na?
Yeah, formula between the cluster data points and the cluster number which is assigned. This also is taking actually a formula of the distance only, but it's a little different scaled formula. It does some scaling to it and then it computes. Okay, the formula is quite complicated for this, so we'll not require that.
We do not need that.
Yeah, we don't need it. The idea is that it is basically on how much of the variance of the data is my model able to explain, just like R2 score. Okay, very similar.
Mhm.
Yeah, any other question? I think somebody was saying something. Any question?
I was just asking the formula of Silhouette score, but you mentioned that it's complex. So
You can look at that. Even I don't clearly remember it because it is a slightly tricky
And
formula.
the DF, the parameter DF should be pre-processed. No?
Yeah, pre-processed, scale DF. Whichever,
Yes.
see, not pre, the idea is whichever DF you're using for the model, that DF it should be. Right? Same to same.
Yeah, same to same, and that should be pre-processed.
Yes. For better score, it has to be pre-processed. Yes.
Hmm.
Okay, so this is the shell out score formula. And these are actually, this B's and A's, these are within cluster means actually, but it's quite complicated. There's a whole mathematical derivation to come at that. So let's skip it, I think. It's better to skip this. Otherwise, it will become very confusing.
Yeah.
R2 score is easier to understand because the formula for R2 score is quite simple. It just compares the variances. But for shell out, it's slightly more involved, but the crux comes to the same. It is comparing variances.
does R2 score also apply to k-means?
No. R2 score does not apply to k-means, but shell out score is a R2 score version of k-means. So you can think of it like a k-means version of R2 score. The formula
R2 score
actually
is
for shell
applied to
out is
what
pretty
models
simple.
exactly?
Can you repeat once again?
What models is R2 score applied to?
Regression models. You have to use for regression, right?
And I think PC also.
No, PCA is not a model. PCA is just a dimensionality reduction technique. It's not a model. You don't have any score for PCA.
Don't we maximize variance in PCA?
PCA, the variance score that is there, that means the components it has taken, how much of the variance of the original data can the subdued components take up. That is what is there. Yeah, R2 score is a little different. It is that how much of the variance of the data does your model understand. In PCA, there is no model.
Okay.
In R2, we have a model. Okay, so it's on that. PCA is a pre-processing technique. So
Yeah,
it's cleaning, data cleaning.
It is part of the data cleaning.
Yes. And R2 score is for model building.
If the number of feature points are many, then it reduced by the PCA, right?
Yes, exactly. And you get those features which explain the data very well. Like suppose the data is explained by 10 features, but out of them 8 are very important. So I can just skip the other 2. That's the idea of PCA.
Correct.
Okay. Yeah. Okay, so this was about main thing. There's one more thing in k-means. Before that, if you have any question on so far, like building the model, pre-processing, getting the cluster labels, and evaluating with inertia and the shell out score. Any question on this so far? It's very simple. Like it's just like regression. It's just that some new terms have come up. That's all.
No, sir, no question.
Okay, great. So now let's look at the last topic for k-means. After that, we have spectral clustering, which is called as dip scan clustering. That we will take up in the next session because I'll explain how that works. Because I think in MLT we have not covered that as far as I remember. So I will explain the algorithm and the code for both. Okay, so that we'll do on Thursday. For k-means, we have
Okay,
one
sir.
thing, which is how to select best value of k. We should know, right? What is the best value of k? So can someone tell me, to get the best value of k, which is a hyperparameter, what is the technique?
HPT.
HPT is a technique, right? Because HPT helps us to get the score with all different parameter combinations, and it gives us the one with the best one, right? But the problem is HPT works with grid search and randomized search in sklearn. Both cannot be used here. The problem is because grid search and randomized search both work with X and Y. So if you remember, you do this, right? So grid dot fit X comma Y, right? That's what we do. So because there is no Y here, we cannot fit grid search and randomized search here. So hyperparameter tuning works in a little different way. We are doing hyperparameter tuning only, but without grid search and randomized search. We have to do it more manually. Okay. Now, how do you do it manually? For that, there is a method. It is a very well-devised research method, which is called as the elbow method. Okay. You might have heard about it in MLT as well. So what does elbow method mean? Elbow method is very simple. I will take different values of k, of course, to whichever I'm experimenting with. I will compute the inertia, the total inertia for all those values of k, just like what we do in hyperparameter tuning. And then I will see, I'll create a graph of them. Okay, so I'll just show you the graph here. So let's go to elbow method in k-means. Yeah. So what I'm doing here is very simple. I will take different, just a second. I'll take different values of k. I will compute the inertia. Okay, this is just the inertia or the error for all these values, and I will plot a graph. Now from the graph, I think you can assume that 9 should be the value, right? Which we are taking, isn't it? Should be 9, right? Because the error is minimum for 9 as value of k. But elbow method
Yes,
does
sir.
not work with that. Elbow method is slightly different. Elbow method will take that value of a k where the graph bends like an elbow.
Yeah, yes, exactly.
Yeah. So if you see, the graph is bending like an elbow at this point 3, right? And 3 is thus the optimal point for clusters. I'll ask you a very important question here.
We
You
can
can
also choose 4. We can also choose 4
Yeah, 4 is
because
also fine. It is also a bending point. 3 will be the natural one, but 4 is also fine. You can use that. Okay. Tell me one thing, like with a good thought process, what we want always is minimizing the error, right? But the error is getting minimized at 9 or 8. These are the lowest points, right? Then why am I taking 3 and 4? Why is it a good method?
Tangent, we are taking tangent.
we will overfit if we take so many.
Yeah,
Like,
overfitting is one good reason. Yes, if we take too many clusters, we overfit. The second is, if you think of k-means is a very business oriented algorithm, right? Like you segment customers. I want to segment those customers who are my frequent buyers and those customers who are not my frequent buyers. What will I do with 9 clusters in that case? Right? So generally for k-means, the clusters that I require have to be meaningful to me as well, right? So if I say the first customer segment is extremely high buyer, then little less extremely high, then little less extremely high, that doesn't make any sense, right? To segment them into so many baskets. Okay, so that is why from an optimal business perspective where k-means is used, we segment them into less number of clusters so that we can analyze and get the differences in a better way. So even though the error goes very low for the 9 clusters or the 10 clusters, we still stick with 3, 4, 5 because that is more oriented to solving our problem. Okay, that's the idea. That is why the method is called elbow method. Wherever the graph bends in an elbow, that is the method where you actually end. Okay. Any question on this? All good with elbow method? Very simple. But the idea should be clear that whenever the graph is bending as an elbow, that is the method, that is the point where you actually stop. Okay, so
Yes, sir. Clear.
yeah, clear, right? Okay, runtime.
How we will decide after plotting the graph only?
Yeah, we have to plot the graph because there is no grid search support here, right? So we have to actually take different values. We have to compute the inertia for all of them, then plot the graph and then see. So we have to do that, like the whole thing.
Visualization is required.
Yes, we have to use either Seaborn or Matplotlib, something like that. We have to use for this. Okay. So let's try a different thing. Let's take a value of k here. Let's take 1, 2, 3, 4, 5, 6, and 7. Right? These 7 values. Let's take, and let's try to see which value of k does the best. Right? So can you tell me, like, how do we? There is no function. There is no sklearn function to do elbow method. You have to do it manually. So what do you think? What is the way of doing it manually? What is the easy way of doing it?
Code for loop.
For loop, right? Best, because manually, if I fit 7 clusters, it's going to take time, right? So we have to
that is the only way.
That is the only way, right? So what we'll do is we have to compute the inertias for all the 7 values, right? So let's create a list of inertia. Yeah, inertia in an empty list. What we'll do is we'll just fit the k-means to all of these values, and then we will just append the inertias and then plot a graph, right? Simple. So what we'll do is for I in k, we will basically do k-means. Okay, so k-means is equal to, we have to initialize the model as well, right? Because k-means will take different values at every point. So it's going to be k-means. We have to do n clusters
is equal to I,
right? Because it will take different values at each run. And random state we can put. Random state is optional here, but of course in the OPP you have to put. So let's get used to it. Then what we'll do is we'll simply fit the model, k-means dot fit df, right? And then what we'll do is we will do inertia. We'll just append the inertia, right? So inertia dot append k-means, same thing, right? We have to just compute the inertia for this and append it to the list dot inertia. Okay, so inertia, sorry. Okay, I've written
Spelling is wrong for inertia.
Now it's fine, right?
No, the last one also.
Okay, done.
Inertia.
L.
Oh yeah. Thank you. Right. Okay, it's done. So let's see
Can
the
you please share the data set as well, please, on which you're working now?
data set is this one. I've created it in the code itself. It's not a file. You can paste this and just run it on pandas and you'll get the data set.
We can make a function also, no? It will give always that function.
Yeah, you can make a function and then just run it on different values. Yes,
That is better.
that is a better
no?
method. Yeah, that is a better method.
Yeah, because
Functions is
here
always better. Like write functions and then just keep reusing them. That is better. Okay, any doubt with this code? Very simple, right? What we are doing is we created a list of all the values of k we want to tune at. We created an empty list called inertia because we have to see the inertia for each value, right? Then we just ran a for loop where we created a k-means model with each of these cluster centers one by one. We fit them, we got the inertia, and now we are ready with both the lists, which is the inertia as well as the k. Okay, so let's see both the lists. So k is ready and the inertia is also ready. Okay. So now what we have to do is we have to just plot this as a graph and we have to see where the k-means is taking an elbow or where it's looking like an elbow kind of a structure is getting created. And once we have got that, we can simply do the elbow method, right? So can someone tell me how do I plot this? A quick recap of matplotlib. So let's import matplotlib. So import
matplotlib.
Matplotlib.pyplot as plt.
Pyplot as plt.
Yes. Now plt.plot, right?
Plot.
And we will do, we can say k and inertia, right?
K and inertia.
It will do the job. So let's, okay, and I'm sorry, I'm making a mistake here. Yeah, so this is done. So what do you think is the point I should take? Should I take 2 or should I take 4? Which is better?
3.
3, sir.
3, right? Because the actual elbow bend is coming at 3. Right, so if you plot it, even 2 you can take. Like in elbow method, there is no hard value. You can actually take some close values as well. But 2 or 3, any of 2 or 3 will do a job. 4 is reducing the loss too much, so we can say that it's kind of overfitting or it's kind of not able to do the business solving aspect which I was talking about. So it's better we stick with either 2 or we stick with 3. Right, one of these is better. Okay, so this is the elbow method. Any question on this? Any doubt?
Sir, could you please show the code?
Yeah, I'll show the code.
There is no formula to get this, no?
No formula, yeah. Okay, the sklearn has not given any formula for it. It's just that you have to get inertias and then plot it out. The reason there is no formula is because the elbow is not very specified, right? We have to manually interpret what is the elbow here. There is no actual method that this is the elbow. Actually, even better than 3 is 2. It looks like 2 is the point of bending. So 2 looks like the elbow, but 3 also holds a better argument. It's also a point of bending and the loss is even lower than 2. So it looks better. Okay, so there are a lot of debates on this. So that's why it's not a very universal method. So that's why sklearn does not have any inbuilt support for it. We have to manually run it and check.
Here, as per the DF, we have age and income. So it has made the clusters for both separately.
Yeah. No, same cluster. It has taken the same cluster from both the features.
Okay, so it is making a combination of 23,
It's a combination of age and
45,000 like
yes,
this.
it's a combination of age and income.
Okay, so it is treating it a row as a data point.
Yes, row as a data point. So that means this has these. So these are the data points, right? This age and this income is the first point. This went into the cluster.
But then how the mean is calculated over here for the row?
Separately for both of them, but then they are merged together in the cluster. Okay. So basically the idea is first you do it for age, then you do it for income, right? Both the means and all. Then you assign the points based on age and income together. Like basically you compare it to the age mean as well and the income mean, and whichever both of them are less to, that point it is assigned to. Okay, so parallelly it happens for both, and then some minor adjustments and those things happen, but rest won't be difficult.
So, scaling will be done in one shot, na? Age and income both.
Scaling is one shot. I'm talking about the clustering going on. Scaling is one shot only. It will do the processing for both of them together, age and income.
And the why is clustering one by one?
No, because age has a different mean. No, even in scaling, it is one by one, right? Age will be scaled separately and income will be scaled separately. It's just that in the code, it's parallel, right? But the views will happen individually, right? Because age will be scaled with the mean and variance of age, and income will be scaled with the mean and variance of income.
Correct.
Yes. That's the thing.
So
So
nothing is
why?
required to be do separately. No, everything
No,
is
no,
done.
no. In code, everything is together. Internally, it works separately, but in the code, you have to just write it once for
Yeah,
all of them.
inertia is calculated separately, right?
Yes, yes, for separately for all of them. Yeah, Disha, any question?
Yes, sir. What is the need to use for loop?
Because you are doing the same thing for 7 values, right? So to make it simple, we'll do for loop so that we can do it for all the values. So initially, it will do k-means with one cluster, fit, then get the inertia, and that comes here, right? Then k-means with 2 clusters, this becomes 2, fit, inertia, that inertia comes here, right? So it's automatic, right? The same task. That's why we are using for loop.
Okay, sir.
Okay, so that's the thing. You can do it separately also, but for loop is going to save your time, right? Separately, if you write, you have to write many lines of code, right, for doing that. Okay, so that is done. Yeah, one more thing by mistake got skipped, so I'll just cover that as well. So when you're doing the k-mean, so I told you, right, you have to take a look at few attributes. One was the labels attribute to see which are the clusters, right, which that each point got assigned into. Second was inertia to see the loss, right, how good is the clustering. One more attribute is quite important, so that you can do as k-means dot cluster centers. So what cluster center does is it gives you the mean value. The mean, we are comparing distance to the mean of each cluster, right? So what is actually that mean? If you want to see what those means are, that cluster centers give you. So this is these are 7. So at the moment we are using k-means with k is equal to 7. Okay, so that's why these give you 7 values. So it is basically giving you the mean of age for each cluster and the mean of income for each cluster for all the 7 clusters. Okay, let me do it with 3 so that it's
Pardon,
little.
pardon. What is it is giving
Yeah,
this
I'll
array?
show it with 3. I'll show it with 3. That will be easier to understand.
Yeah.
Basically, what this is doing is for every cluster, you are actually computing the distance of the point from the mean, right? From the cluster mean. So when you do k-means dot cluster centers, it actually gives you those
Cluster
means.
means individual clusters.
Yeah, there are 3 clusters, right? Cluster 1, cluster 2, cluster 3. For
Yeah.
each cluster, you have 3 means: mean of age and mean of income for all the 3 clusters, right? And
Yeah.
from there, we are comparing the distance of the points and seeing which point belongs to which cluster, right? So when you do cluster centers, this means this gives you the means for each cluster. This is for the first cluster. This is the mean, age, and income. This is for the second cluster. This is for the third cluster. Okay. Why is age and income negative? The data is not negative. So how is the mean negative?
Scaling was
You have
done. No?
scaled it, right? Standard scalar, -1 to 1.
Yeah, it is -1 to 1. No? So it is scaled.
Yes. So if we were doing min-max scalar here, everything would have been from 0 to 1, right? So then we would have not seen any negative value. So that's just the difference of scaling. But in the inertia and all those things, it doesn't make a difference. You can use any scalar. It's fine.
Which one is better?
Both are fine. Actually, it depends on case to case basis. The generally people use standard, but even with min-max, I have seen it with a few cases, it gives the same result almost. So it's okay. In the exam, if it is asked, we will specify. Like we'll give you use this scalar or use that scalar. It will be specified. As such, in the OPP, this won't be asked because this is not a part of OPP, right? This is week 9. So this will be directly in the end term. So for the end term point of view, remember the scaling part. Remember the
in the end terms, such kind of things will be asked like that. Na? Numbers are given. We have to calculate and get the result. Is it like that?
yeah, for clustering, it won't be asked like that because it is very difficult to calculate all this.
That's why I'm asking, no? Because
No, wherever it is easy to calculate, that will be asked.
Okay.
Yeah, for clustering, what can we ask? Like we can ask you, we can give you a graph here, right? And we can ask you with a clear elbow, which is the actual number of clusters to be used. So wherever you'll see the bend, that is the number of clusters, right? So those type of questions can be asked. Then what are the hyperparameters? Like n clusters is a hyperparameter. Then what does cluster center represent? That is the mean, right? So those things you should know from clustering. And what is inertia? Inertia is a squared distance, right? The lower the better. So those things should be clear. Rest everything is easy, right? And scaling. Why scaling is important? Because it's a distance-weighted algorithm. So that makes it converge faster, right? When we scale. So that is one more thing. And grid search is not possible because there is no Y there, right? So that is why we have to apply elbow method manually. So these type of questions can be asked. And then we have the next type of clustering, which is the hierarchical clustering, which we will see in the next class. Questions on that can also be asked in the end term. This is of course more important because this is the standard clustering algorithm, but the other one is also quite popular in some cases. So we'll be looking at that as well in the next session. Okay, so
Okay, sir.
yeah, I think that is all for k-means. If you have any other question, let's discuss that. Otherwise, we can wrap up as well. I'll share this collab with you on the calendar so you can find out the link there.
Yeah, please share.
Sir,
I'll share a
have you?
whiteboard as well so that you can
Sir,
write it down. only. Otherwise, in the calendar also I'll share it.
Sir, have you
Sure, here.
participated in any other Kaggle competitions? Like they give prizes, and I saw the prize pool for like dollars and stuff.
I have not participated in any paid one. Unpaid have participated in many, but not in any paid. You can participate. The prize pools are quite big if you do a good job. You can participate.
Only the top the leaderboard number one gets that prize.
One, I think it's one. Some only one gets, and some 1, 2, 3 get. It's like that.
Oh,
But many big prices are there. I have seen $10 lakh like that.
Yeah.
$100,000.
Because some of the competitions actually are for inventions for the company, inventions and innovations which company use. So when you give them a very good model or something, the companies incorporate those models to their work as well, right? So that is
Okay,
why
okay.
it's actually kind of a internship you're doing for them if you win the competition.
Whether some person in our IIT data science course have won any competition?
I think they have. I saw on LinkedIn sometimes somebody had won a big competition last year, I think.
Rare. It is rare, one or two like
Yeah,
that,
yeah,
right?
because the whole world participates, right? And even very advanced researchers, everyone participates. So it is very difficult to win them, but it is a good practice. We can try them
No,
out.
but I propose that because this IIT is the only course in India which is dealing with the data science, the
Huh?
innovative
I
course.
I don't think there are other colleges that